All right, so number 1, we have y equals 2x squared minus x. Is this equation written in factored form? No, it's not. The ones you had in the video last night were already in the 2 sets of parentheses. This one is not, so we need to factor it. So first, let's see if we can factor out a GCF. Is there a greatest common factor within those terms? 2. We can pull a 2 out of them. So when we pull out a 2, we'll have y equals 2, and then we need to divide each of those terms by 2. So if we have 2x squared divided by 2, what's that going to leave us with? Just x squared. The 2's will cancel. And if we have minus 8 divided by 2, will leave us with minus 4. So we move that GCF out, divided it out. But is this still factored completely? No. We can still try to factor it into 2 sets of parentheses. So that y equals 2, that all stays the same, but we want to put the x squared minus 4 into 2 sets of parentheses. So the first term in each of those has to be an x, so that I get x times x gives me x squared. But the second term in each of those have to multiply together to give me negative 4. So what multiplies to give me negative 4?
2 and negative
2 and negative 2, or 1 and 4. But we want these to cancel out to give us a middle term of 0x. So we want them to be the same, so we're going to do 2 and 2. 1's going to be negative, and 1 is going to be positive. So we multiply it out, we'll get plus 2x and minus 2x, which cancel each other out. So we'll just have x squared minus 4. So this is the completely factored form of our polynomial. So this is the one that we're going to use for the rest of our steps in order to graph it. We've just rewritten the equation in another way. We've factored it. So our next step, number 2, is to find the x-intercepts. Okay? We said to find the x-intercepts, we plug in 0 for y. So we'll have y, our 0, equals 2 times x plus 2 times x minus 2. And to solve for x, we set each piece that has an x in it equal to 0. So we'll have x plus 2 equals 0, and x minus 2 equals 0. X plus 2 equals 0. We'll have to subtract 2 from both sides, so we'll get x equals negative 2. And we have to add 2 to x plus 2, so we'll get x equals positive 2. So those are our 2 x values for the x-intercepts. Are the x-intercepts a point or a line? They're a point, so we want to write them as a point in the coordinates. So negative 2, how do we write that as a point? Melanie? Negative 2, 0. The x value is negative 2 and our y value is 0. And again, for x equals 2, we'll have the point 2 comma 0. And now that we have these, we want to put both of them on our graph. So we'll have negative 2, 0 over here and positive 2, 0 over here. Right. So now that we know our x-intercepts, we want to find our axis of symmetry. And we said that has to cut this in half. So it also has to be right in the middle of our x-intercept. So what's between negative 2 and positive 2? 0 is in the middle. So our axis of symmetry is going to go right along x equals 0, which in fact is the y-intercept. And is our axis of symmetry a point or a line? It's a line. So we aren't going to put coordinates for our axis of symmetry. We're going to put an equation, which in this case is going to be x equals 0. Because we've drawn our line everywhere where x equals 0, up and down. And again, we use a dashed line for the axis of symmetry. So next we have to find our vertex. Well, we said our vertex always has to occur on the axis of symmetry. So since the x value, bless you, since the x value at our axis of symmetry is 0, we want to plug in 0 for x and see what we get for y. So we use our equation. We'll have y equals 2, and then we'll plug in 0 for x plus 2 times 0 minus 2. Just plug in 0 for both of those x's because 0 is the value of our axis of symmetry. And whenever we multiply this out, we're going to have 2 times negative 2, which gives us a value of negative 8. So that'll be our y. So our vertex is going to happen at 0, negative 8. So we can plot that on our graph. 0, negative 8. Well, notice, where is 0, negative 8 happening? It's on the axis of symmetry, but what else is true about the axis of symmetry in this case? It's also the y-intercept in this case. Won't always be, but in this case, we automatically know our y-intercept has to be 0, negative 8, because that's where it's crossing the y-axis. So now that we have all of those pieces of information, we're going to draw just a rough curve for our graph. So you want to make a nice U shape going through all of those points. That switches direction at your vertex, that's where it turns. And notice our graph looks like it's open up. If you look back at our equation, is our equation a positive or negative equation? It's a positive. We have that 2 in front, a positive 2. So it does make sense that it should be opening up since it's positive. Our last step is to state the domain and range. The domain, we said, was all the possible values we could plug in for x. So the x-axis goes from left to right. Could we keep plugging in things to the left, farther and farther to the left? Does our graph keep going that way? Yeah, and our graph keeps going to the right. So we can plug in any value for x. So we could say all reals. But there's this fancy symbol that sometimes we use because we're too lazy to write out the words all real numbers. So we use this fancy R. That means all the real numbers. And basically, it's just an R that has 2 sides on it. So you can either use the fancy symbol for R for all reals, or you can just write all reals. They mean the same thing. Our range has to do with the possible values for y. So we want to look, is there a minimum or maximum that happens on this graph? Is there a top or bottom to our graph? There's a bottom, okay? Where does that bottom happen? What point is that on the graph? It's negative 8, but what's that point called? It happens to be the y-intercept, but what else? The vertex, okay? Our minimum or maximum is always going to happen at the vertex because that's where it changes direction. So looking at our vertex, our value for y is negative 8, and our y's are going up, they're getting greater, so our range is going to be all the y's greater than or equal to negative 8. Question? Alrighty, number 2, we have f of x equals x squared minus x minus 2. Again, f of x is just another way to write y equals, okay? Tells us this is a function. So we want to rewrite this in factored form. Is there a GCF we can pull out of all 3 of those terms? No. So we want to try factoring it into 2 sets of parentheses. So my first term in each of these has to be an x, so that when I multiply them together, I get x squared. And the second term in each one has to multiply together to give me negative 2, and then when we add them, we have to get negative 1x. So the possible ways to get negative 2 are 2 and negative 1 or negative 2 and 1. Which one of those combinations is going to give me a total when we add of negative 1x? Negative 2 and 1. So I'm going to do x minus 2 and x plus 1. Okay? If you need to brush up on your factoring skills from last chapter, Power Lunch would be a great way to do that. You can look back at the notes or the videos from last chapter, but you will need to remember how to factor. Right? So we have this in factored form. So now our next step is to find our x-intercepts. So that happens when y equals 0. So we're going to put 0 for y is equal to x minus 2 times x plus 1. And now to solve this for x, we just set each piece equal to 0. So we have x plus 2 equals 0. So what does x have to be? In this case, x has to be negative 2. We would subtract 2 from both sides. Right? And we have x plus 1 equals 0. So x would give us a value of -1. We'd have to subtract 1 from both sides.
Wait, how did you get x minus or x plus 2 if it's x minus 2? Yeah.
Oh, I'm sorry, I wrote that wrong. You're right. This should be x minus 2 equals 0, so that means x has to be positive 2. Thank you. Right? So we found our two x-intercepts. Again, our x-intercepts are points, so we're going to write them as points. So we'll have our points are 2, 0, and -1, 0. And we can put both of these on our graph. So I'm going to graph 2, 0, then graph -1, 0, both along the x-axis. And now I want to find my axis of symmetry. So we said our axis of symmetry happens in between the two x-intercepts in the very middle. So to find the center of those, we can look and eyeball it, or we can also just take the average of the two numbers of the two intercepts. So to take the average, I would add those together. I would have 2 plus -1 and then divide by 2 will give me the average of those two numbers. So that'll give me 1 over 2, or 1/2. So that means my axis of symmetry.
Why do you put it over 2?
Because I'm finding the average of the two numbers. So if you add two numbers together and divide by 2, it gives you the average.
But every time you have to divide by 2?
If you're trying to find the average. Yep. Right, so our axis of symmetry happens where x equals 1/2. So again, we have our axis of symmetry is a line, so we write it as the equation x equals 1/2. And we're going to draw that where it cuts through between where x would equal 0 and x would equal 1. So next we want to find our vertex. Okay, for our vertex, where does our vertex have to happen? Does our vertex necessarily happen along the y-intercept? No, but where does it have to happen? It has to happen on the axis of symmetry. For it to be symmetrical, that point where it changes direction has to be on the axis of symmetry. So, what does the x value have to be in our vertex? What's the x value for our axis of symmetry?
0.
On our axis of symmetry? 1/2. Okay? So since 1/2, or x equals 1/2 is our axis of symmetry, then we know the x value of our vertex has to be 1/2. Do you say why? Because if we have our graph, the line of symmetry, Ellie, always has to go through that bottom point, through the vertex. If you drew a line of symmetry through something else, it's not symmetrical over that line. Okay? So the line of symmetry, the axis of symmetry, is always going to go through the vertex, which means that if we find what the x value is at the vertex, it can tell us what the y value is going to be. Okay? And we know the x value of a vertex because it's the same thing as the axis of symmetry. So if x is 1/2, we can plug that into our equation to tell us what y is going to be. So we're going to use y equals, and we'll plug in 1/2 minus 2 times 1/2 plus 1. So I just plug in 1/2 for x into my equation. And I want to go do the parentheses first. So 1/2 minus 2, that's -1.5. And 1/2 plus 1, that's positive 1.5. Which, when I multiply them together, that gives me y is equal to -2.25, I believe. So if I write this as a fraction, I'd have -2 and 1/4 would be my y value. So my vertex, again, we said was a point, and that point happens at 1/2, -2 and 1/4. So if we plot this, it's going to be at x equals 1/2, which is along our axis of symmetry, and y equals -2 1/4. So just below the